Hey guys, we're back with another video, and in this lesson we're going to be looking at the graphs of tangent and cotangent. So we've already looked at how to graph sine, cosine, and cosecant and secant. So we're going to utilize some of those same techniques there to graph tangent and cotangent. But first let's look at some of the properties of this trig function. So we have to remember that tangent of x is essentially sine of x divided by cosine of x. And because of this, we can say that tangent of x will equal 0 when sine of x equals 0. So from our unit circle, we know that this is at 0, pi, 2 pi, and so on. And also from this understanding, that we could say that tangent of x is going to be undefined when cosine of x equals 0. So think of when cosine of x equals 0, that's we're going to have negative pi over 2, pi over 2, 3 pi over 2, and so on. All right, so undefined, graphically, we should know by this point in the course that that's going to appear as a vertical asymptote. So we have vertical asymptotes, we have, we'll know where the zeros are going to be located. So I have on the screen right here, just the basic graph of tangent of x. And you can see that how it appears differently than the sine, cosine, and their reciprocals, where they would oscillate. Tangent doesn't oscillate. It has one form, and we're seeing that one form repeated within certain intervals. So if you look carefully at the video, a couple of things that we can write down about tangent is the period of the tangent function. This goes with cotangent. Unlike sine and cosine and their reciprocals, where the period, the length for one cycle is a distance of 2 pi, so we went from 0 initially to 2 pi, here the period for tangent is only a distance of pi. So we're going to see this interval. You saw me up here write negative pi over 2. We're going to look at this interval going from negative pi over 2 to pi. Okay, so that is one difference already with the tangent function and cotangent, is that our period is shorter, and with tangent, again, we're on a tangent right now. With tangent, the interval we're using is also different. So understanding that these endpoints here are vertical asymptotes. That's why we're starting at negative pi over 2 rather than 0. Because if I went from 0 to pi, there would be a vertical asymptote within that interval, and when we go to graph, it's not going to be useful for us to use that interval. So we're going to use negative pi over 2 to pi over 2 for tangent. So also looking at a graph on the screen, we see that the zeros of the graph, or the x-intercepts, are located, as we already should know, x equals negative pi, 0, pi, 2 pi, and so on. And then we see on the video, as we've already written down, that we have vertical asymptotes located at x equals negative pi over 2, pi over 2, 3 pi over 2, and go on 5 pi over 2, and so on. So we had with the period, if I wanted to find the period of tangent, we had a certain formula for it. And actually, I'm going to wait a little more to tell you this formula. No, I'll tell you right now. Right now is a good time to tell you. So unlike sine and cosine, the sine and cosine, the and symbol. So for sine and cosine, the period was going to be 2 pi divided by b. For tangent and cotangent are our period we find by dividing pi by b, just pi. So I think the 2 pi, where that came from, that's the basic period for sine and cosine with no vertical shrink or stretch. So since tangent and cotangent have a basic period of pi, that's why we're not seeing the 2 there. Okay? So we're going to use this later on. So now let's examine the cotangent function. So cotangent. So if we see now the cotangent, I'm going to switch out the tangent picture here for the cotangent. We see that cotangent, or we should know by this point, that cotangent of x is essentially 1 over tangent of x, which instead of saying sine over cosine, it's going to be cosine of x over sine of x, which helps us understand, again, where our zeros are and where our vertical asymptotes are. So because of this understanding that cotangent is cosine over sine, cotangent of x is going to equal 0 when cosine of x equals 0, which was at pi over 2, or negative pi over 2, pi over 2, and 3 pi over 2. And then cotangent of x is going to be undefined when do you think? Well, when sine of x is 0, so that's negative pi, pi, I should have thrown 0 in there, 2 pi, 0 in here. Okay? So the period of cotangent is still pi. The length of the period is still pi, but the interval of it, since we have vertical asymptotes at 0 and pi, much like how we used the vertical asymptotes up here as the ends, for cotangent, we're going to be using the vertical asymptotes of 0 and pi to designate the ends of our interval when we go to graph. So 2 key differences with cotangent and tangent. So with the zeros, just copying it over here, so we have zeros located at negative pi over 2, pi over 2, 3 pi over 2, and so on. We have vertical asymptotes at, well, negative pi, 0, pi, 2 pi, and so on. All right? So continuing here, we're not going to graph yet in this video, but I would like for us to just examine some cotangent tangent functions and identify what the period is and what the interval of that period is. So let's look at a couple examples to close this video up. So let's say we have, let's title this identifying period length and tangent and cotangent. So amplitude, we identify that the same as we would sine, cosine. Okay? So with tangent and cotangent, let's say we have y equals tangent of 2x. So by the end of our lessons for sine and cosine, you started seeing me place this inner part of the function between 0 and 2 pi, and I would solve from there to get my endpoints. Okay, if you forget this, I'm going to put a link here on the screen to take you back to that video just to remind you. But with the period of tangent, we use the basic interval of negative pi over 2 to pi over 2. Okay? So to solve for x, we divide by 2. So when I divide both sides by 2, we would get negative pi over 4 and positive pi over 4. So our interval would be negative pi over 4 to positive pi over 4. That's our interval. But the actual length of the period is going to be pi divided by b, so pi divided by 2. So we have our interval, and we have the length of that interval. Let's try another. So say we have y equals, let's say tangent of x divided by 3. Let's see what happens here. So negative pi over 2, x divided by 3, positive pi over 2. So to solve for x, we multiply each side by 3. That gives us negative 3 pi over 2 x, positive 3 pi over 2. So we have our interval. But the interval, knowing what the interval is doesn't exactly tell us the length of the periods. The period length is going to be, let's see, pi divided by b. B is not 3 in this situation, otherwise it would be just 3 times x. B is actually 1/3, and dividing by a fraction, we flip it and multiply by the reciprocal. So this is actually the same as saying pi multiplied by 3 over 1, or just 3 pi. So the length of our interval is 3 pi. So how does this change? How does this look different when we have cotangent? So with cotangent, let's say we have 5 cotangent of, I don't know, let's say we have 3x, okay? So with cotangent, the basic interval is different than tangent. So with cotangent, you can rewind back to the beginning of the video. The basic interval for cotangent is 0 to pi. So to solve for x, we divide by 3, which leaves us with 0, which leaves us with 0, x, and then pi over 3. All right, so interval. And we find the period the same exact way as tangent. Pi divided by b. B is 3 in this situation, so our period length is pi over 3, and we can actually see that from the interval. It's easier to see when our interval starts at 0. And obviously, I left the 5. The 5 is the amplitude, guys, and you should know that by now. So I wish you the best of luck. You should be, at this point, practicing identifying the period length and the interval for tangent and cotangent. And then in the next lesson, we're going to actually use this along with our tools from graphing sine and cosine to graph tangent and cotangent functions. So best of luck in the practice, and I'll see you in the next video.